And welcome everybody to the Daily Space Weather. We're starting out this video by looking at the sun here in ionized carbon and iron. So these aren't the normal wavelengths that we always look at. We've been creating a little bit of a stir here at the Smash News Network, least busted name in news, talking about ionized carbon. Where does it come from? Where do the heavy elements come from in general? We've got a massive solar uptick that's been going on the past couple of days, and a lot of these sunspots have not even been counted yet. Also, the radio flux has ticked up. Perhaps no surprise there to our regular viewers. Here's a closer equatorial view. And what's super interesting about these wavelengths, folks, is that you see this area here where it's kind of dark. That's an area that's very low in carbon and very low in iron. These bright areas are very high in carbon and very high in iron. So the blue part is the ionized iron. The yellowish part is the ionized carbon. So if we subtract just the ionized iron, there's just the carbon by itself. That's 1600 angstroms from SDO. And it looks like a huge fusion factory happening there. And I won't get into the controversy associated with the chemical spectra of the solar surface at the moment. We do have some recommendations of some further reading for you, though. So let's take a look at sunspots here before we move on to a whole bunch of daily space weather data. So here is yesterday plus today in SDO continuum, and once again there are like 3 of 5 sunspots that didn't get names yet. So we've got one here, 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 and here. So only 3 of those 5 got names yesterday. Expect the other 2 to get names today because, well, that's just what happens. I don't know why such a delay. I mean, a lot of those sunspots were there since yesterday's video. So, again, you can expect at least 3 more named sunspot groups today. And the sunspot number, as we said in yesterday's video, I guess it became a forecast. This is colorized magnetogram, by the way. Yesterday's video, we forecasted that the sunspot number was pushing 200. It might even exceed 200 after all those other groups get named and all the rest of the umbrae get counted. So, anyway, not sure what's going on with that. It's maybe somebody's on vacation. But in any case, the uptick continues. And if you thought the sun was shutting down, think again. It's just a ridiculous notion. Let's see what's going on planet Earth for a moment. Guess what? Krakatau's erupting. So there's some great imagery of Krakatau, daughter of Krakatoa. One of the best volcano names in the world, Krakatau. Sounds like a volcano exploding. And it's not a major eruption, although it is explosive in nature. Let's see what else is going on here for today, June 7th. We've got a Biko producing a 12,000-foot ash plume. We've got Sakurajima producing an 11,000-foot ash plume. Suwanosejima, 6,000-foot ash plume, flight level 060. So no indication of ash plume size there, about 657 meters. So like about a 2,000-foot ash plume there over Krakatau. Dakono, flight level 070 as it explodes. That's located on the Isle of Halmahera, Indonesia. Popocatépetl also exploding, flight level 210 over central Mexico, and flight level 210 over Peru from Sabancaya. By the way, it's smoky, very smoky in eastern Pennsylvania right now. We'll get to that in our meteorology segment. As far as global seismicity, it's been pretty inactive. Only 3 quakes over a 5+ magnitude for the past 24 hours. And here is the quake rundown. We will cite quakes of a 5 magnitude and higher, which means not a lot of action in the past 24 until we get to 21:48 Universal Time yesterday, where we saw a 5.2 north of New Zealand there near New Caledonia. Then just under an hour later, 50 minutes later, we saw a 5.2 at the Loyalty Islands, basically in the exact same location as that other 5.2. That one was slightly deeper at 33.1 kilometers. And then South Sandwich Islands, 25 seconds after midnight. So early this morning at 0 dark Zero dark zero in 25 seconds. There was a 5.1 near the South American / Antarctican plate boundaries. And that's it. Those are all the quakes of a 5 magnitude or higher. And let's get back to space. So now we've put together a video for you here. This is all ionized iron, 211 plus 171 angstroms. This shows great depth and great filamentary activity. You can see those coronal holes there. We expect those to become geoeffective in about 3 days. And there is a possibility of a CME impact today. We'll be keeping an eye out for that. And here we've subtracted the 211 angstroms to show just 171 angstroms by itself. There are some additional coronal mass ejections. We'll show you those as well a little bit later in the video. And let's take a look at the Space Weather Enthusiast dashboard next to see what's going on. First, ionized helium for the past 24 hours. So there is the SDO 304 angstroms wavelength. And when we get to the filament section of the video, we're going to show you some sweet imagery indeed. Check out the size of that filament in the northeastern limb. That would be your upper left. It is quite spectacular indeed. All right, so let's take a look at some solar stats. The 10.7 centimeter radio flux is currently at 172 solar flux units. And if you're a new viewer to the channel, thanks for leaving comments, Mike. If you're a new viewer to the channel, leave us a comment. Let us know where you're located. And here is the location on the sun where that radio flux comes from. It's from the upper chromosphere and lower corona, right about there. And it is a proportional data set to sunspot number. Once again, we are expecting this to come up to around 200 along with the sunspot number. I'm not sure why this is showing so low here. This needs a refresh big time. But sunspot number is going to be approaching 200 when those 3 additional sunspot groups get named. Those are just facts. And here's NOAA's forecast. This is the Space Weather Prediction Center. And NOAA isn't forecasting any sort of geomagnetic unrest except a brief period tomorrow. And I have no idea why. So we'll just have to see if that occurs. It'll be on that'll be on Friday's video, whether or not NOAA was right with that forecast for geomagnetic unrest on tomorrow, Thursday, June 8th. Anyway, again, expecting a minor CME impact basically at any moment here within the next couple of hours. So here are the past 4 hours of Earth's magnetic moment from space. It's a geospace magnetosphere movie that we show daily. And for everybody who is frightened that Earth's magnetic field is evaporating, well, there is a model of it based on a lot of data. If you want to figure out where that data comes from, where the model comes from, click on the Details tab on the Geospace Magnetosphere Movies page, and you'll find a link to the Space Weather Modeling Framework. You can download the software and create your own if you think that it is somehow inaccurate or fake. Next, our ground magnetic perturbations map. Again, it's the last 4 hours. This is Earth's magnetic moment from the ground. It depicts magnetic flux density. It uses the same model. It's based on all kinds of features like electron flux, magnetometer data, solar wind telemetry, and significantly more. So calm conditions here on planet Earth. At the moment, we are expecting a possibility of a KP 6.33. Depending on the magnetic field, density, and duration of the CME impact that some of us forecasted for today. Current conditions are KP1, very geomagnetically calm. If we do see a signal, it should be significant. Here's a real-time solar wind data. And again, there was a little CME impact looking sort of a thing happening here. It was very weak. I mean, it didn't even really include a significant change in the magnetic fields. You can see just a plasma temperature signal there. I mean, that's barely even noteworthy. Current conditions are the solar wind is very slow and very diffuse. Only 327 kilometers per second for the solar wind speed. Solar wind density barely 1 proton per cubic centimeter. Again, when we do see a CME impact today, which is likely, expect to see a significant signal. We may have to make a second video, and by the way, we are making a live stream this afternoon, so make sure you join us for that. We'll be doing our standard issue. Now it's back, the Wednesday afternoon live stream. So join us around 3 p.m. We'll be starting once again. And let's move to magnetic data. There are your GOES magnetometers as measured by the GOES 16 and GOES 18 in their geosynchronous near equatorial orbits. You can expect to see some variations in that when a CME impact strikes as well. Next, we'll look at the heliospheric current sheet. And I would attract your attention, as I've been for the entire solar cycle, really, this bit of magnetism right here. That is a North Pole-oriented coronal hole at the North Heliographic Pole. It's got to leave, and when it does, expect a significant further uptick in solar activity. Stars appear to be governed by their magnetic field behavior, and this is associated with the mechanism underlying the solar sunspot cycles and probably all stellar activity cycles. Of course, we know a lot more about the suns as Earth's been orbiting it for, shall we say, a lengthy period of time. And again, look for that green blob of magnetism there to leave that area and be replaced with a red blob, South Pole-oriented magnetism. And we do have a sector boundary crossing approaching as well. So if you look up the latest image here, we're about, it could be as short as, let's see, we could see this sector boundary crossing show up as early as in tomorrow's video. But I would suspect it'll probably take about an additional 30 hours for that to show up. It all depends on whether the sunspots in the northeast grow or shrink, or if new ones form in the southern hemisphere. For that matter, just keep in mind the magnetic environment can change with basically zero warning. So here's our line of sight field plot. You can see the solar B field depicted here in blue, magnetogram in grayscale, solar polar fields in red for south and green for north, which brings us to coronal holes, which are now an important feature. As I said before, this one up here at the North Heliographic Pole, let me move that. Hey, that didn't work. Let me try that again. This coronal hole right here is sort of the link between where the sun is now and solar maximum. So the south solar polar field migrated pretty quickly, and it hasn't sort of replanted itself at the North Heliographic Pole yet. But the north polar magnetism has been hanging out there throughout the entire solar cycle since about November of 2019. So anyway, that's the current situation. And let's take a look at coronal holes here from the perspective of SDO for the past 24 hours. There you go. Some rather cavernous coronal holes there on both sides of the equator. And they are both North Pole oriented. Let's bring up the last image. We do have some South Pole coronal holes here rotating in. They are kind of trans-equatorial, so we might see some... Excuse me. We might see some fireworks from those South Pole-oriented coronal holes over here. The sector boundary crossing is like in this area right here. So again, we can expect some coronal hole high-speed streams from these as they become geo-effective in about 3 days. And let's move to sunspots. Yeah, sunspots. By the way, counting sunspots is not going to somehow produce insight into how the solar cycles work. Stars, they're a lot weirder than you may think. They're probably a lot weirder than most astronomers think. And I suspect they're a lot weirder than Neil deGrasse Tyson thinks. No offense to Neil deGrasse Tyson. Anyway, we've got like 3 more sunspot groups that need to get names. They're located up here in the northeast and the southeast. This large one down here is at least beta gamma class, and I believe the most likely one continuing going forward to produce large solar flares remains 3327. So it's number 11 over here, 10 or 11. You can see pretty high likelihood of solar flares. I believe 3327 remains the most likely player for large solar flares. So let's take a look at sunspots, and magnetic fields. Now, we talked a little bit about magnetic shear yesterday because, well, we even put up a short that like 4 people actually saw that says you too can forecast solar flares. It all has to do with being able to recognize the magnetic shear. It's basically just some math that you can do. And keep in mind, folks, this isn't just pictorial. This is data. So it's showing you magnetic field intensity and orientation. And then it's showing you how much ionized iron is emitting extreme ultraviolet radiation in the 94 angstroms wavelength. So that's SDO magnetogram plus 94 angstroms to show active regions. Here we've subtracted 94 angstroms. And most of these groups are quite stable since yesterday. Not a lot of changes happening. Again, we expect 3 more sunspot groups to get named today. Sunspot number should be pushing 200. It should be very close to 200 once those groups are all covered. They named like 2 of 5 yesterday. So, yeah. There's your SDO continuum. Again, not a lot of evolution of those groups in the past 24 hours. Things have been pretty stable. Which brings us to energetic particles and solar flares. The definition of instability: putting out X-rays and blasting out relativistic protons. It's a big deal. We ain't got none. The solar energetic particles have been absent for a long time. Largest flare of the past 24 happened earlier this morning. It was a peak flux of C7.15. And only C-class intensifications have occurred over the past 3 days, as you can see here on our 3-day chart. And don't shart in your pants, because we've got more data to show you here. Here is 94 plus 131 angstroms. The 2 wavelengths from SDO specifically formulated to view solar flares. Keep in mind they are not X-ray, but they take more images per minute. They're still extreme ultraviolet. They're both ionized iron, once again. And here's the zoom into the equatorial portion. Again, the most active region there is down in the lower left, the southeastern limb. So how about a close-up of that? What do you say? There's some pretty sweet imagery for you, complete with the Earth scale to show you the size of those giant plasma filaments and clouds of fusion happening before your very eyes there. There's a lot of heat and pressure happening in that area. A combination of solar gravity, magnetism, and electromagnetism, and all sorts of different chaotic processes happening as mankind becomes more and more aware of the reality that is astrophysics. A crazy, crazy field. And it's a great time to be doing such things because, well, there's about to be some, shall we say, paradigm shifts when it comes to the understanding of cosmology, heliophysics, etc. So let's take a moment to just look up. We've got a setting gibbous waning moon here over Lehigh Valley, Pennsylvania. That is our star chart. And it's probably pretty orange at the moment, as it is quite smoky in Lehigh Valley, Pennsylvania. Next, your solar system forecast before we go to things like coronal mass ejections and solar filaments, which is pretty spectacular once again. Here's your 1-week forecast for the solar system. Mercury making its way across the gas giant side of the solar system over there. Somebody will say this is a thing because, look, oh my God, you've got the Sun, Mercury, and Neptune lined up, and then you've got Uranus, Jupiter, and Saturn lined up, which makes a plus sign or something, and that's really, really scary. So make sure you sound the alarm bells for that, because that, oh my God, I'm so spooked. By the way, folks, the planets are not going to kill you. The planets do not control the sun's activity or anything like that. It's just a ridiculous and idiotic theory. Now, what's not idiotic is our paid affiliate / sponsor, Hemp Lucid. Well, that's one of them. So check out the links below the video, help support the channel, and perhaps help support your health. Make some improvements, maybe to your sleep, your stress management. What about your performance? Yeah, there are focus mushroom gummies. CBDs do all kinds of things to all types of people. If you haven't checked them out, check them out. You can get the lip balm, makes great gifts. Enter the promo code SMASHOMASH to save 10% on your checkout. Again, or shop via our link. Doesn't hurt to do that. You'll find that below the video and on our homepage located at smashomash.com. Thanks to everybody who has picked up Hemp Lucid products. And leave us a comment if you have. Let us know what you've been into and how it's been working out for you. Again, links below this video as well as on the homepage at smashomash.com, the official homepage of the Smash News Network, least busted name in news. And if you think that's a dig on CNN, it absolutely is, because we have a certain faith. We have a certain dedication to be fanatical about one thing, facts, or you could say the truth, either way. That is what we are about. This is a good faith endeavor to advance not only cosmology, but human technology. And welcome to the Neo-Renaissance. Today's featured product from the Amazon store, which we just added some books and other things to the Amazon shop. So check that out at amazon.com/shop/smashomash. Links below the video and on the homepage to that as well. It's the shirt I'm currently wearing. I'm a massive collector of Hawaiian shirts for over 2 decades at this point. And if you're thinking that one is the background of Frank's office in the movie Scarface, it is not. It is slightly different, but it is similar. I love the pink and orange lava colors. They go great with my standard Smash News Network hat. Again, check out the products there. Today's featured merch item is Do the Math, Sagittarius A star, the Milky Way's galactic core. Now, back in the mid-90s, we used to call this a massive radio source. Most people will call it a supermassive black hole nowadays. That doesn't really offend me. It takes a lot more to offend me. And, like, derogatory comments in the videos do not offend me. However, they do amuse me. So, whatever you're doing, do the math. 8 = capital D. Don't foment science nonsense on YouTube. Although, if you've got some plausible theories, we're more than happy to listen to them. I am not closed-minded when it comes to science. I just know quite a bit about physics. I started studying cosmology and astrophysics in about 1979 when I was about 3 years old. I guess I've dated myself now, but in any case, you are invited to do the math. The word quantum does not make a thing magic. Chemtrails are not real. And the universe is not electric. Quantum is not magic. The universe is not electric. And chemtrails are not real. If you don't believe me, just do the math. We've conveniently placed the equation all over this merch. 8 = capital D. It's a very important equation to share with herp-derps on the internet. And let's take a look at coronagraphs. So there you go. There are some coronagraphs, and you'll see the tail end of a... We meant to put up yesterday. There's yesterday. You see a CME erupting there from the northeastern limb. It's got a dense core. It's a great example of a multiple impact. Like if that struck Earth, that would have multiple impacts. You'd have a leading edge. You'd have a very strong core and possibly an elongated filament there, or maybe a trailing edge. Coronal mass ejections take various different shapes, and those shapes do continue to propagate through space. We see evidence of that when they actually strike Lagrangian point 1, and we get solar wind data about it. So those are yesterday's frames. That's 106 frames from yesterday. That spectacular CME from the northeast is not expected to have Earth-directed components. Here are today's frames, an additional 28. And there is some activity actually going off as we produce the video. If it's anything of note, we'll probably produce another video. Here's some more data from Soho Lasco C3 as well as C2. The last set just showed C2 and some computer interpolation of that. Again, some minor CME just happened. It's also looking like it is out of the east-southeast, which would be on your left. We'll also show stereo A's coronagraph. And we show this diagram because stereo A is overtaking the Earth and stereo B are overtaking each other. It's a bad time to try to calculate trajectory based on stereo A's data. Here's stereo A on the left and Soho Lasco C3 on the right. So the likelihood of coronal mass ejections is super high, as we've got lots of filaments on the Earth-facing portion of the solar disk. And let's take a look at some of our custom SDO plus Soho Lasco C2 and C3 films. There you go. There's a great clip of the past 24 hours. 2 coronagraphs plus SDO 193 angstroms. And you can see a little bit about how huge this filament is up here in the northeast. Don't worry, we'll show you a close-up of that as well. Here's a slightly closer view of the latest coronal mass ejection activity. It's all out of the east side. It's all out of the east side. So it looks like the South Pole-oriented heliospheric current sheet has got a little bit more action. Again, it's on the way. We're expecting that to arrive about 30 hours from the time this video was created. Here is a close-up view. That's 193 angstroms plus the Soho Lasco C2. And here's just 193 angstroms. And let's get to filaments. So filaments are giant chunks of plasma, giant magnetically suspended strings of plasma there, as you can see all over the surface of the Earth-facing portion of the solar disk. All those dark regions there. I mean, there's a great one. We got a huge prominence over here. That is a really spectacularly huge prominence. Again, don't worry, we've got close-ups of that for you as well. Check out this filament down here becoming unstable. It actually, very interesting there. You can see it actually grows. It almost looks like this solar flare added material to it. Anyway, those filaments are suspended up there. There are a lot of them. The likelihood of coronal mass ejections, possibly even Earth-directed ones, is nearly 100%. And let's get back to solar imagery. So here is SDO 193 angstroms once again. And here we've zoomed into the northern hemisphere and added 304 angstroms. So that should add a little bit of additional contrast there. Check out that filament in the northeast. It's a little bit larger than the Earth. And we don't even know how long that might be, whether it is primarily going north to south. Who knows? It's a giant filament regardless. And you may see 2 other filaments up here, like this one here by the crown. That's another Sirius filament. Would you like some closer imagery of that? Well, there you go. The one that we're expecting to strike today didn't look all that dissimilarly from that. Some mesmerizing plasma activity there around the north heliographic polar region. Giant filaments pepper the Earth-facing portion of the solar disk. So here's the equatorial view. So not only have filaments grown in the past 24 hours, more filaments are rising up there in the east. More sunspots are about to get named. It's a general uptick in solar activity. It could be off to the races. Again, we are waiting to see that North Pole coronal hole leave the North Heliographic Polar area. That'll be sort of the final seal being broken before we could declare solar maximum. Anyway, that's what's going on, and that brings us full circle. Let's look at the past couple of hours here on the GOES SUVI. We'll zoom out just a little bit. The great wide field of view there from the GOES 18 SUVI is fantastic at showing CMEs as they happen. And check it out, a new filament. We got a crown prominence hanging out down here by the south heliographic polar region as well. So lots of stuff going on here. And again, we'll be doing a live stream this afternoon at about 3 p.m. Eastern Time, which brings us to our bonus features segment. Satellite charging hazards are non-existent. It's smooth sailing. No charging hazards of the internal or surface charging variety. Goes electron flux here kind of low, and you can expect this to get as low as it gets when and if a CME impact occurs later today. At the moment, we're just in a low range there. There is the 1-year graph from Solon.info on the relativistic electrons. The greater than 2 mega electron volt electron fluence. There's NOAA's forecast. We are expecting it to be roughly here instead of where NOAA has it. A minor distinction. It shouldn't really cause very much to happen. We'll have to see what occurs there. We also like to show the ionosphere daily on the channel. It's basically just to archive the data. You never know when amassing data could lead to incredible discoveries. Scott McIntosh would tend to agree. And if you don't follow us on Twitter, you ought to, as we share lots of important info on Twitter that nobody else gets to see. Also, the Smash team. Anyway, here's the vibration of the F layer of the ionosphere. That's usually located at about 300 kilometers of altitude. Keep in mind it does change altitude a bit. Geomagnetic storms puff it up, and solar inactivity makes it retract. So in any case, that's what's going on in terms of vibration in megahertz, millions of vibrations per second for the past day. If you want to look at it yourself, it's on the Australian Government Bureau of Meteorology website. And here is the anomalygram also. That is the anomaly in megahertz from the 30-day median. You may see some weirdness right here. That is because that is the South Atlantic anomaly, the Earth's weakest point in its magnetosphere, right about there. And the second weakest point is right about here, the west coast of equatorial Africa. So that's sort of the weakest zone in Earth's magnetic field right there. And you can see that portrayed very well in the ionosphere anomalygram. Anyway, nothing exciting happening there. Let's bring up the latest image. It's 11:15 Universal Time ionogram and 11:15 Universal Time anomalygram. Total electron content depicts free electrons to about 12,500 miles of altitude. Your GPS satellite is located in the inner portion of the outer Van Allen belt. It's got to communicate through this plasmasphere, this inner Van Allen belt, this plasmasphere, and the ionosphere. Free electrons cause signal refraction. And here is the total electron content forecast. And we do see some electrons quite far out of place here. So some significant GPS errors, perhaps at unexpected locations like the southern portion of the Indian Ocean, the Southern Ocean. So some large and significant magnetosphere activity happening there. And some GPS errors, perhaps in locations where you may not expect them to be. So again, that's literally just a count of free electrons from about 12,500 miles down to the ground level. And since we're on North America, we'll show the North American total electron content also. So this may contain some signals that may be important for detecting seismicity. There may be a pre-earthquake signal that shows up in the total electron content. That's why we show this one daily now. And we're not claiming to forecast earthquakes, but we're claiming that nobody's forecasting earthquakes. And by the way, we got to make a lengthy video with Mr. Bagashov. If you don't follow him, follow Eugene the Philosopher. Yeah, Eugene the Philosopher. Shout out to Eugene. That's the total electron content anomaly from the 10-day average over North America. And we're seeing less anomalous signals than we did in yesterday's video. See yesterday's daily space weather video for additional information about that. We'll close out the space weather section with the latest intensity gram and latest colorized magnetogram. First, let's look at this new large sunspot that just rose down here. And it is beta gamma delta class, or beta gamma class. I'm sorry, not beta gamma delta, just beta gamma class. This one up here is definitely beta gamma delta class. So anyway, here's your rock back of those two sunspot groups. This one's got a lot of magnetic shear. And again, multiple new groups up here that will get names. There's 1, there's 2, there's 3. This one down here doesn't have a name. So I think we're looking at 4 new named sunspot groups today. If you have been banking on the sun shutting down, cash in those assets, because that theory is not even a theory, it's a hypothesis, and it is highly debunked. By the way, if you enjoy the content, make sure you press like, subscribe, share, etc. on YouTube. If you're viewing any place besides YouTube, you BitChute viewers, what are you doing? You're missing like 98% of the content by only subscribing on BitChute. You're missing our cosmology segments and all of our playlists generally. So check those out if you haven't seen those. Some fantastic content there that is highly underwatched on our playlists. There's also original music there by our record label, Golden Cap Productions. Again, a live stream coming this afternoon, so join us for that. And let's get to meteorology, as we're known to do. And what we're looking at here is dust extinction, because we've got some air quality alerts here in eastern Pennsylvania. Let me get off the screen. First thing we're starting out is the Dew-X, and check it out. Saharan dust is blasting across the Atlantic Ocean, tamping down weather systems. You can see right here we've got a high pressure zone right here rotating clockwise, as they're wont to do in the northern hemisphere. Again, Saharan dust fertilizes places like the Caribbean, and it also tamps down weather systems. Yeah, dusty air is a lot less likely to produce big tropical systems. So all that dust in the central Atlantic there is not going to help increase the likelihood of hurricanes. Let's take a look at the PM. Let's look at the PM 2.5. Check it out. That's a particulate matter of 2.5 micrometers. A micrometer is about 1/10 the size of a human hair, by the way. So, and there you can see a lot of particulate there around the east coast of the U.S., all the way from Cape Cod down to Virginia Beach and beyond. And that is all from Canadian smoke. It's the Great American Canadian Smokeout. It's enough to make you go out and ride your bike and go ride uphill to see how much smoke you can inhale before you start to lose aerobic quality. Yes, I like the extremes, folks. These sorts of weather things cause me to go outside and do stuff. Anyway, let's move to our regularly scheduled meteorology segment. Here is the surface wind scenario. It looks like this system has re-intensified here off the coast of the Philippines, or maybe a new one's formed. I think a new one actually formed. So a new strong low there east of the Philippines. Could be the windiest place in the world. We're not going to worry about it. Here are the jet streams of that side of the planet. We start with the east because those folks are ahead of us. Yeah, those are advanced folks over there. People like Kimberly and Dirk are advanced. In other words, they're experiencing, well, they're almost in tomorrow by now. Anyway, incoherent jet stream continues over the U.S. Look at the huge bends in the jet stream up here over Arctic Canada. You got this south to north and north to south flow. Incoherent jet streams are what's causing a lot of weird weather in the U.S. And here are the surface winds of this side of the planet. Thanks for all the smoky air, the great sunrises and sunsets. Canada. There are the surface winds of the central world, and these are the jet streams. Here's our carbon monoxide map, and there is a lot more carbon monoxide than normal in eastern Pennsylvania, all of New Jersey. It's a bad air quality mode, thanks to all that Canadian smoke. It's a Canadian smokeout, folks. The Canadian smokeout. Carbon monoxide, one of the great features of windy.com. Many layers available there. Everything from the UV index to the ozone layer. Next, we'll show you clouds and fog over the Americas. Shout out to our viewers from both continents. Congratulations on realizing the channel exists. We're frankly surprised with the pathetic, putrid, and disgusting state of censorship currently, as certain organizations attempt unwillingly to destroy perfectly viable businesses because we're trying to advance the actual science. Here's your weather.gov map. If your location is lit, click your location. Those are largely air quality alerts all around the Great Lakes, the Northeast U.S., etc. Air quality alerts. Also, it's super dry in Pennsylvania. Rain is desperately needed. We're like 3 inches behind normal here. So not only are there issues with air quality, there are also issues with the possibility of starting wildfires. Weather.gov, if your location is lit, click your location, and let's do a jet stream forecast. This is what the jet stream's expected to be doing. It's the GFS 72-hour forecast for the 250 millibar winds. The jet stream is going to remain incoherent here. So it looks like it's going to pull through, but then it kind of breaks down. Expect the weird weather patterns in the U.S. to continue. And no, it's not because mankind is controlling large-scale weather patterns. That's just an idiotic and ridiculous notion. If you think mankind is able to control the weather or the climate in large scale, take a physics course, just one, preferably physics 1 and 2, but for goodness sakes, folks. The idea that mankind is able to control the weather and climate is the pinnacle of arrogance and ignorance. Here's our GFS 72-hour temperature anomaly forecast, as it's going to remain cool in most of the eastern portion of the U.S. for the next 3 days. The only anomalously warm portion will largely be the northwest. Keep in mind that is in degrees Celsius. That's a 72-hour GFS temperature anomaly forecast. Last but not least, the pressure and precipitation forecast, based on the same model, the generally accurate GFS 72-hour forecast. And we don't show 3-week forecasts on the channel because I'm not an imbecile. What I am able to do is do extremely precise weather forecasts for specific locations. I'm able to tell you whether or not a hurricane is going to intensify or get weaker based on understanding the physics. We hope you understand the physics. And let's get to lightning. That's your GFS 72-hour pressure and precipitation forecast, courtesy of tropicaltidbits.com. So here's lightning. Once again, Texas seeing some lightning strikes. No surprise there, as they get storm after storm after storm after storm. And here's a real-time lightning map from blitzachtung.org or lightningmaps.org if you prefer. There is our global lightning map. And by the way, thanks to the Smash Team. These videos were brought to you in part by Smash Team Silver and Gold level members. The best value is the Gold annual paid-up subscription. It's almost like getting 4 months of a Gold Smash Team member. Gold level Smash Team membership. It's like getting 4 months for free, as it includes complimentary merch. So that's the best value. The Gold membership is otherwise $9.99 a month. The Silver membership is $2.99 a month. It'll entitle you to additional content. There's also a Bronze level. We send out email alerts even to Bronze level members. And we sent out one yesterday, actually. You have to be logged in, though, at smashomash.com/smashteam. So now we're looking at a smoke map. This is at fire.airnow.gov. And there are the smoke alerts. And again, quite a bit of smoke here, making it all the way from Alberta to San Antonio, Texas. And then all the way from Ontario and Quebec all the way down to, basically to Florida. So pretty smoky. I find it fun. Here's our U.S. Doppler radar map. This is showing vertical motion in the air column. It's not going to show you smoke. It's going to show you water and ice crystals moving up or down. Mostly down. And there are the lower 48. There is the clouds and fog scenario. We've got this low up here by Maine that has taken its time moving down to the southwest, and that is what is causing all this cold air and smoke to blow down from Canada. It's all because of this low up here. And it'll be more obvious in the water vapor map. There's water vapor. You can see this low is kind of right over the Canada-Maine border right now, just north of Maine, it looks like. We've also got some sandwiching here. Once again, we've got a sort of a blocking feature over here. This is effectively slightly higher pressure as we've got cold air blowing down and then dry air down here. We've got moist air here, which is a relative low, and then we've got dry air over here, which is a relative high. Another blocking feature down here. Dry air is more massive than moist air at a given temperature and pressure. And here's your recap. U.S. Doppler radar from ground-based systems. Clouds and fog, 3.9 micrometers on space-based systems. And the water vapor map, which depicts all the water vapor. If you folks in Texas are confused about what's going to happen next, just consult the water vapor map. It will hook you up. And if you want any specific forecasts, we might hook you up. This afternoon, make sure you join us at 3 o'clock at the Smash News Network, the Busted Name of News, for our weekly Wednesday live stream. Thanks for tuning in, everybody. Thanks for leaving comments. John and Mike, thanks to everybody who tuned into the premiere. And don't forget to visit links. Press the share button, as the algorithms make no sense on YouTube. Anyway, we'll see you soon. I'm headed back to the bunker. In the meantime, may that solar wind be at your back. Bunker time. Bunker, take me away like Calgon. Whoa!